All right, we're looking at the schematic for the SureShot Mobile. The schematic is very, very, very similar to the schematic for the original model rocket launch controller I did for the Scouts a few years ago. We have two voltage sources. We've got a 9-volt battery and we have a 12-volt launch battery. The 9-volt is what drives the electronics. The 12-volt is what drives the launching of the model rocket. You can see we dropped that 9 volts here down to 5 volts through a typical voltage regulator. You can switch that out if you have issues. You want the battery to last longer, basically, either to an LDO, low dropout, or maybe to a switching regulator. Recom, I think, sells one that's pin for pin compatible, a switching version. They're kind of expensive, but it's up to you. Then you've got the D1 Mini. The D1 Mini is basically driving everything, and the software is really what's important in this case, and we'll take a look at that in a few moments. So you've got GPIO pins controlling a MOSFET, which is handling the launching through this relay. You've got another pin here looking at continuity. So yeah, I mean, that's basically all there is to this. The software is the D1 Mini is running the software for the web server and all the logic that's going on. And when the right buttons are pressed, the MOSFET is fired and basically sends this relay over, which causes the 12 volts to go to the igniter and off your rocket goes. So pretty simple stuff. All right, with that, let's go take a look at the software. If we look at the libraries that I'm using, you'll find that we're using the ESP8266 web server, some Wi-Fi stuff, and we're using the file system, little fs. So if I toggle over and take a look at the folder here, you're going to see that there's a data. So this is where our INO is, which is the Arduino file, the project, if you will, I guess. And this data directory here contains the HTML and the images, and that's actually what gets copied onto the D1 Mini via setting up this, and let's see, it's called right here. We have the ESP8266 little fs data upload. So that's puts the files onto a little file system on the D1 Mini, so that then, as you'll see, we can reference those files via the web server. So let's go ahead and take a look. We've got a description here of which pins are being used. We've got a function prototype set up. We've access point credentials. It's something I haven't finished. You can certainly finish it, and it wouldn't be a bad idea to add your own security credentials to this. That way, basically, when you go to connect to your SureShot mobile access point, you would have to provide some credentials so someone else could not get on the access point. And there's even code, like I've done some settings stuff. I kind of worked on it a little bit, but it's something you can finish. I have to move on to another project at this point. We've got some launch configuration information that we store in the EEPROM space, the EEPROM space. We create an instance of a pointer to a web server. You know, this is just typical stuff. You know how the setup works. It gets called once, and then we go into the loop. So we go and we set up our pins properly, what we're going to read from, what we're going to write from, set maybe some initial pin values. We set up the little file system, and then we have some calls to do things like handle the Wi-Fi DNS. This was probably set up because I was looking. Oh no, this is actually set up so we know what the web server can call. There was originally talk about maybe doing this with a captured portal. So there could be some code in here that references that. I never got it working like I wanted to, so it just never happened. So yeah, so this basically sets up the web server, sets up all the references to what function is going to handle what call. So if a user calls index.html, we call handle root. So this basically sets up a map, if you will, for the web server to call. Then we start in our loop. And most of these loops are very much like state machines. So you're trying to remember where you are, and you're going to see that as you look through this code. It's pretty much a state machine. We got a reset button, check here. We call the DNS process next request. We call handle client. If you want to do a launch, we check for certain things like continuity here. And remember, what's going on is the website is actually calling through its JavaScript some of these things every second or every couple seconds to find out, do we handle continuity? This is the continuity check. Are we ready to launch? Are we going to stop the launch? All of these calls are handled inside here, but more importantly, let's take a look at the HTML in that data directory. So if we open this, let's see, we'll open it in, let's see, where is, there it is, Notepad++. Okay, hopefully this font is big enough. So what you see here is the basic HTML for the page that you pull up. I'll show you a picture of it here. And what you've got going on here is the drawing of that page, but really the initialization like of the launch controller. So what the value should be for those controls, you know, the checks and how often they're going to take place, continuity check, how often it's going to take place, the button, and somewhere in here, as you look at all this code, let's see. All of this code is reacting to the events for the controls on the HTML page. If you press a button or not, and then it checks certain statuses. What I wanted to show you was like the continuity one, because it's kind of interesting. You can see that when continuity check needs to be made, we create an XML HTTP request. We call continuity on the D1 Mini. We look at its results, and we can determine whether we have continuity or not. And these document object model calls here change the information that's on the page that you're looking at. This call is on a timer, and that is set for, you know, every 500 milliseconds, it looks like. So that's pretty much how this works, is you've got an HTML page, you've got a web server on the D1 Mini, you've got that web page reacting to events like the pushing of the launch button, or in this case, the timer going off, and then it calls the web server and gets some information back, such as, you know, what the continuity is. What the continuity is. Let's take a look at that. Start launch. This is like one of the easiest ones to really understand, because once you get this concept, you understand that whole client to server communications and handshaking that's going on. So when this gets called, remember it's being called by the HTML page, and then we actually need to check the continuity on the pen, and then we send back a string through the web server with a value of either 1 or 0. Is it good? Is it not good? And that's as simple as it gets. All right, well, all of this code is, as I stated with the schematic, is available online. You're welcome to change it, enhance it, and make things better.
Yep, he said go for it. Okay,
Okay, guys, watch.
come in, come to the blankie. Turn around, Cole. You can't see it. It's right there. Turn around.
It's not loud.
Ready?
Point to it.
Here he goes.
Woo! No, see where it landed?
So that was a lot of fun shooting off those model rockets. It worked flawlessly, which is certainly a new thing for me to have something actually work that I make without a lot of, iterative going back to the bench and fixing things. But that's probably because obviously I had used the design earlier and this was just a modification of a design that I'd gotten working. So I hope you enjoyed it. I hope you build yourself one and have a lot of fun. Some things that you could do to make it better. We talked about the voltage regulator idea, where you could go to a switching voltage regulator. It might be kind of cool to add some additional sensing to it. Maybe while you're looking at the screen on your smart device, you could see what the launch battery voltage is, what the internal battery voltage is. You might be able to make the user interface nicer, more responsive to the screen dimensions that it's on. You could do all sorts of things. Add the security for the access point would be probably a really good one to add, even if you just hard code it in to your version. So anyway, I hope you had a good time. Stay tuned. Remember, learn something new every day, and we've got more projects coming. Thanks. Hey, subscribe if you haven't, if you want to. Anyway, take care.